Welcome to my little corner of the internet, where we celebrate creativity and growth. Greetings, viewers. Get ready to immerse yourself in the world of Leclanché cell in this video. Thumb up right. 1919 illustration of a Leclanché cell. The Leclanché cell is a battery invented and patented by the French scientist Georges Leclanché in 1866. The battery contained a conducting solution electrolyte of ammonium chloride, a cathode positive terminal of carbon, a depolarizer of manganese dioxide oxidizer, and an anode negative terminal of zinc reductant. The chemistry of this cell was later successfully adapted to manufacture a dry cell. Let's now turn our attention to history and examine its role within the larger context. Thumb up right. Samson battery. No. 2. A Leclanché cell battery manufactured by the Samson Electric Company of Canton, Massachusetts, c. 1868. In 1866, Georges Leclanché invented a battery that consisted of a zinc anode and a manganese dioxide cathode wrapped in a porous material, dipped in a jar of ammonium chloride solution. The manganese dioxide cathode had a little carbon mixed into it as well, which improved conductivity and absorption. It provided a voltage of 1.4 volts. This cell achieved very quick success in telegraphy, signaling and electric bell work. The dry cell form was used to power early telephones, usually from an adjacent wooden box affixed to the wall before telephones could draw power from the telephone line itself. The Leclanché cell could not provide a sustained current for very long. In lengthy conversations, the battery would run down, rendering the conversation inaudible. This is because certain chemical reactions in the cell increase its internal resistance and, thus, lower its voltage. These reactions reverse themselves when the battery is left idle, making it good for many short periods of use with idle time between them, but not long periods of use. Now, let's shift our attention to construction. The original form of the cell used a porous pot. This gave it a relatively high internal resistance, and various modifications were made to reduce the resistance. These included the agglomerate block cell and the sac cell. Leclanché first, and Carl Gartner later, both strived to transform the original wet cell into a more portable and more efficient dry cell. Porous pot cell. In Leclanche's original cell, the depolarizer, in fact, the oxidizing agent in the cell, consisting of crushed manganese dioxide, is packed into a pot, and a carbon rod is inserted to act as the cathode reduction reaction. The anode oxidation reaction, which is a zinc rod, is then immersed along with the pot in a solution of ammonium chloride. The liquid solution acts as the electrolyte, permeating through the porous pot to make contact with the cathode. Agglomerate block cell. In 1871, Leclanché dispensed with the porous pot and replaced it with a pair of agglomerate blocks attached to the carbon plate by rubber bands. These blocks were made by mixing the manganese dioxide with binding agents and pressing the mixture into molds. Sac cell. In this cell, the porous pot is replaced by a wrapping of canvas or sacking. In addition, the zinc rod is replaced by a zinc cylinder to give a larger surface area. It has a lower internal resistance than either of the above porous and agglomerate. Starch addition. In 1876, Georges Leclanché added starch to the ammonium chloride electrolyte in an effort to better gelify it. Improved dry cell. In 1888, a German physician, Carl Gartner, improved the gelification process and produced a more portable dry cell by mixing plaster and hydrophilic chemicals with the ammonium chloride electrolyte. Moving forward, we'll be taking a closer look at chemistry. The redox reaction in a Leclanché cell involves the two following half reactions. Anode oxidation of Zn plus E equal volts. Cathode reduction of Nev, 2 No plus N plus E 2 No plus 2 E equal 1.23 volts. The chemical process which produces electricity in a Leclanché cell begins when zinc atoms on the surface of the anode oxidize, that is, they give up both their valence electrons to become positively charged Zn ions. As the Zn ions move away from the anode, leaving their electrons on its surface, the anode becomes more negatively charged than the cathode. When the cell is connected in an external electrical circuit, the The excess electrons on the zinc anode flow through the circuit to the carbon rod, the movement of electrons forming an electric current. The potential difference in charge over the anode and cathode is equal to the difference of the two half-reaction potentials, producing a theoretical voltage of potential energy across the terminals. A variety of factors, such as internal resistance, lower this output value to the 1.4 volts measured from these cells in practice. As the current travels around the circuit, when the electrons enter the cathode carbon rod, they combine with manganese dioxide NO and water HO, which react with each other to produce manganese oxide NO and negatively charged hydroxide ions. This is accompanied by a secondary acid-base reaction in which the hydroxide ions accept a proton H from the ammonium ions present in the ammonium chloride electrolyte to produce molecules of ammonia and water. Since plus 2 Mos plus 2 Nc plus Mos plus 2 Nic plus whole. Or if one also considers the hydration of the Mos sesquioxide into Me-oxyhydroxide. Since plus 2 Mos plus 2 Nc plus 2 Nos plus 2 Nic. Alternately, the reduction reaction of Nivcan proceeds further, forming She hydroxide. Cis plus Mos plus 2 Nc plus Mos plus 2 Nic. In this section, we'll be exploring uses. The electromotive force EMF produced by a Leclanché cell is 1.4 volts, with a resistance of several ohms where a porous pot is used. It saw extensive usage in telegraphy, signaling, electric bells and similar applications where intermittent current was required, and it was desirable that a battery should require little maintenance. The Leclanché battery with cell was the forerunner of the modern zinc-carbon battery, a dry cell. The addition of zinc chloride to the electrolyte paste raises the EMF to 1.5 volts. Later developments dispensed with the ammonium chloride completely, giving a cell that can endure more sustained discharge without its internal resistance rising as quickly the zinc chloride cell. Thank you for watching. I appreciate your support, and I'll see you in the next video.